Good morning, friends. Already we have studied the Newton's law of gravitation in the last period. So today we are going to see the numericals regarding with that mathematical formula. Friends, just I'm going to recall that formula once again so that it will be very easier for us while solving the questions. So what does the Newton's law of gravitation says that every particle of a matter attracts every other with a force which is directly proportional to the product of their masses and inversely proportional to square of distance between them. So the mathematical formula is F is equals to G m1 m2 upon r square. Right, this formula we have studied in the last lecture. So before solving this question, you should be very clear with this mathematical formula. Okay, now we'll see the question. What does the question says? The question says the gravitational force between two bodies is 1 Newton. If the distance between them is doubled, what will be the gravitational force between them? So first we'll write down the given information. So here, as per the given information, we can observe that the gravitational force between the two bodies is a 1 Newton. So F have the value of the 1 Newton, and suppose initial distance is a r. Now this distance will be got doubled, so the final distance is a 2r. So what will be the new force? So that we have to calculate. Okay, now we'll go to the solution of this question. So here the solution is given. Let m1 and m2 be the two masses of the bodies and r is the distance apart initially, then the force will be given by the formula. So here you will observe that the F is equals to G m1 m2 upon r square, and how much is the force? That force is a 1 Newton, right? So that mathematical formula we have written, equation number 1. Now when the distance between them is doubled, so new distance will become r dash is equals to 2r. So as the distance is r dash, so the new force we can write the F dash is equals to G m1 m2. In the place of r dash we can write the 2r bracket square. So the square of 2 is nothing but the 4. So G m1 m2 upon 4r square. That's equation number 2. So dividing equation 2 by 1, F dash upon F is equals to G m1 m2 upon 4r square multiply by r square upon G m1 m2. So if you will observe, so here G m1 m2 will be get cancelled, r square will be get cancelled, so it will becomes 1 upon 4, and F dash upon F is equals to 1 upon 4. So F dash is equals to F upon 4. So 1 upon 4 is nothing but the 0.25 Newton. So the force between the two bodies reduces to 0.25 Newton. Friends, remember here why we have used the word reduces, because the force is inversely proportional to the distance. So here force is inversely proportional to the distance, so inversely proportional to the square of distance. So this quantity increases. If this quantity increases, then the force will decreases. So as the inversely proportional, so if the distance is got doubled, force will become 0.25. So that is the overall solution. Suppose the same question will be asked for the CET examination, then you can solve within a short interval, that based on the mathematical formula, that is a F inversely proportional to r square. So this distance will be got doubled, so F inversely proportional to the now 2r square. So F will becomes 1 upon 4r square, that is a 0.25. So in that way also you can calculate 1 by 4 means nothing but the 0.25. So that is a shortcut method, but while writing in the notebook you can write in detail. So again I'm going to explain here. So two masses m1 and m2 are separated by the distance r. So the force between them is 1 Newton. Now when the distance will be got doubled, so what we have done, we have taken the new distance as a r dash. R dash is equals to 2r square. Now 2r square, that will become nothing but the 4r square, and after dividing equation 2 with the 1, we have got the answer. F dash is equals to f dash upon f is equals to 1 upon 4. Therefore f dash is equals to 1 upon 4. So answer is a 0.25 Newton. So the force is inversely proportional to the distance. So as the distance increases, what we can say, the force will be reduces to the 0.25 Newton. Friends, while writing the numericals, you can pause the video, you can note down the question, then you can note down the solution in the proper way and read it again and again and try to solve once again, so that you will be very clear with that concept. Now the this question will look here overall a simple look. So here you will observe the total question, solution and answer once again. So here the question is given, the gravitation, same question is there, 1 Newton is there, distance between them will be got doubled, so we should calculate the gravitational force. So in one look you can observe the question, again the solution. Friends, you can try to solve the questions at home by taking the distance here. In the place of double you can take the half and you can try to find out the force. So try to solve. In the place of double you can take the triple, half, and in that way once you can increase the value, in one you can decrease the value, and based on that you can draw your conclusions. So this is the first question from the topic gravitation here, based on the Newton's law of gravitation. So this is the first numerical. Now we'll go for the next numerical. Okay, in the second question the data is given. Find the gravitational force between the sun and the earth, given the mass of the sun 1.99 into 10 raised to 30 kg, mass of the earth 5.98 into 10 raised to 24 kg. The average distance between the earth and the sun is 1.5 into 10 raised to 11 meter. Okay, so here what we have to find out, we should find out the gravitational force. So here mass of the two bodies will be given. So we know the gravitational force formula, F is equal to G m1 m2 upon r square. So first mass we can take the mass of the sun, second mass we can take the mass of the earth. Capital G is the gravitational constant, and here the distance between the earth and the sun will be given. So we can write the r is given here. So this we can conclude as a m1, this as a m2, and this as a r. So these values are given to us. So based on that we have to find out the gravitational force. Now we'll move to the solution of this question. Okay, so here you can observe that ms means the mass of the sun. First we will write down the given 1.99 into 10 raised to minus 10 raised to 30 kg. Then me, mass of the earth, as per the given question, me is equals to 5.98 into 10 raised to 24 kg. Remember the units, mass will be measured in terms of the kg. Now r, what is the r? R is the distance between these two. So this is the 1.5 into 10 raised to 11. What we have to find out? The gravitational force between the sun and the earth. So F is equals to G m1 m2 upon r square. This is a mathematical formula. So you can take this as a m1, this value as a m2, and this value you can take as a r. If we substitute this value and if we solve, then we'll get the answer. Remember what is the SI unit for the force? For the final answer, SI unit should be the Newton. Okay, so this is the given information. Now we will move to the solution of this question. So here you should know the constant. As we know, the gravitational constant capital G have the constant value 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Now we should use a mathematical formula. F is equals to G m1 m2 upon r square. In the place of m1, what we have written the ms, mass of the earth. In the place of m2 we have written the me, mass of the earth, and r square is the distance square. So 6.67 into 10 raised to 11 minus 11 into 1.99 into 10 raised to 30 multiplied by 5.98 into 10 raised to 24 upon 1.5 into 10 raised to 11 bracket square. So friends, first you can collect the power of the 10. So 10 raised to 24, 10 raised to 30, 10 raised to minus 11. And remember this 10 raised to becomes 10 raised to 22 here. So you can collect all the power of the 10s. So you can get the answer as a 10 raised to 21. Then you can write all the constants: 6.67, 1.99, 5.98 divided by 1.5 square, 15 square, 225. Put the decimal point, so 2.25. You can solve with the help of the log table, and finally you can get the answer as a 3.5 into 10 raised to 22 kg. So what we can say, that the gravitational force between the sun and the earth is 3.5 into 10 raised to 22 Newton. So friends, I hope you have understood the solution of this question. So this question is very simple. Here two masses are given to us and the distance between them is given, and we should find out the gravitational force. Friends, for this question, the value of capital G may be given or may not be given. So you should always remember what is the value of capital G is a constant, that is a 6.67 into 10 raised to minus 11. So you can substitute here for solving. As I have told you, first you can collect the power of all tens, and then you should keep the numbers as it is, and then with the help of the log table you can do the calculation, or you can use approximation method for the CET or JE examination. Here you may, for the board examination, you can use the log table to do the calculation. And remember, as it is a force, so final answer have the unit as a Newton. So this is our second question. Now we'll move to the third question. Third question says, calculate the force of attraction between two metal spheres, each of mass 90 kg. So if the distance between the centers is 40 centimeter, the value of capital G is given in the bracket 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. So roughly, if you can draw the diagram, you can get this idea that the two masses are there, right? And each is of the 90 kg. M1 is 90, M2 is 90. Now the distance between them is a 40 centimeter. R is equals to 40 centimeter is given. So we should convert the centimeter in terms of the meter. So 40 into 10 raised to minus 2 meter. So centimeter we should convert in terms of the meter. And here two masses are not given separately. In that place they have given that the two metal sphere each of mass means m1 is equals to m2 is equals to 90. So the value of m1 and m2 is same. M1 is equals to m2 is equals to 90 kg. So m1 and m2 have the same mass, and the separation between them is a 40 centimeter. Based on that, we have to calculate. So this question is similar as that of the previous one, but only difference is that in previous question separate two masses are given, and here they have used the word that the two spheres each of mass 90 kg. Okay, now we'll move to the solution of this question. So first we can write down the given. M1 is equals to 90 kg, M2 is equals to 90 kg. R is equals to 40 centimeter. So this will be converted in terms of the meter. So 40 into 10 raised to minus 2 meter. Then the value of G 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. So you will understood that the M1 and M2 are given, R is given, G is given, and what we have to calculate? We should calculate the value of F. Which formula we have to use? The mathematical formula of the Newton's law of gravitation. The F is equals to G m1 m2 upon r square. Now we'll move to the solution of this question. So here in one look you can get understood the given information. M1 m2 is equals to 90 kg, r 40 into 10 raised to minus 2, G is equals to 6.67 into 10 raised to minus 11, and F is equals to G m1 m2 upon r square. Friends, here 6.67 into 10 raised to minus 11, 90 multiplied by 90 upon 40 into 10 raised to minus 2. So here also while solving, remember first we should collect the power of 10. What are the power of 10? Here 10 raised to, you can observe that the power first is 10 raised to So here you can observe the first power, that is a 10 raised to minus 11 is here, 10 raised to minus 11, and here you can observe that the 10 raised to minus 4 will be there at the base. So 10 raised to minus 4, when it will goes to the numerator, so it will become 10 raised to minus 7, right? So minus 11 plus 4, then we can collect the number 6.67, 9 multiplied by 9, 81, 81 into 10 is 8100, then the square of 40, 1600. So again I am going to tell you how to solve this. So after substituting that value, we should go to for the collection of the power of 10. So first you, if you will collect the power of 10, so here the 10 raised to, at the numerator 10 raised to minus 11 is there, and at the denominator 10 raised to minus 4 will be there. This 10 raised to minus 4, when it will be goes to the numerator, it will become 10 raised to minus 7. So 6.67, 9 multiplied by 9, 81, 8100 upon 1600. This 00 will be get cancelled. So 6.67 into 81 upon 16. You can do this mathematical calculation. So you will get the final answer as a 3.377 into 10 raised to minus 6 Newton. So the final answer you can write in the word as the force of attraction between the two metal sphere is a 3.377 into 10 raised to minus 6 Newton. So friends, this question is also based on the previous question. So same mathematical formula we have used here. I hope you have understood this question. Now we'll move to the solution. Now we'll move to the next question. That's a question number 4. Friends, this question is quite interesting, and one kind of the challenging question is there. So because the questions which we have seen the first previously, they are based on the same format, but here the format will be quite changed up. So here you can't get the answer directly. Here you should think a little bit. Three balls of masses 5 kg each are kept at the points 1, 2, 0, comma Q 230 and R 220. Find the gravitational force on the point exerted on the ball at point R. So here if you will observe, these are the coordinates. So as we know that the coordinates of the x-axis, y-axis and z-axis, so this is the coordinate system. So here the x-axis distance is a 1, y-axis distance is a 2 and z-axis distance is a 0 for the point P. Again for Q the x coordinate is 2, y coordinate is 3 and z coordinate is 0. And for R, x coordinate is 2, y coordinate is 2 and z coordinate is 0. So first we should try to draw the diagram, and after drawing the diagram we will get a clear idea how to find out the force. So here remember the three balls of mass 5 kg are kept at the points. So three balls are there and each having the mass of 5 kg. So mass is given to us as well as the coordinates are given to us. So based on that we should draw the diagram. Now we'll move to the solution of this question. Friends, the diagram will plays very important role here. If you are very clear with the diagram, then it will be very easy to you to get the solution, as well as you should be very clear regarding with the vectors which we have studied. So vectors are of two type, positive vector and the negative vector. If here you should be very clear with the vector also. The net force acting at the ball R will be the vector sum of the forces acting at the ball P and Q. So in the coordinate system, so how we have plotted the point P. So if you observe in the given question, the coordinate is x is a 1 and y is 2. For point R, the x coordinate is 2, y coordinate is 2. And for point Q, x coordinate is 2 and y coordinate is 3. So based on that we have plotted the points P, Q and R, and then we have joined up. After joining, you can observe that here the vector PR and here is the vector QR. Now we have to find out the net force. So the net force is nothing but the force acting at point P to the force acting at point Q. So this force acting at point P, force acting at point Q, we should calculate. So that after that we can find out the net force. Okay, so here Fp is the force acting at point P. Now we should find the distance between the point P and point R. We know that the masses are the same. m1 is equals to m2 is equals to 5 kg we can take, but in order to find out the distance you can look about the x-axis. So here 2 minus 1, so r is equals to 1. So force acting at point P we have to calculate. So Fp is equals to G m1 m2 upon r square. So here G m1 m2 5 into 5 5 square and distance Rp is nothing but the 1 square. Now again the direction is very important here. So the force is acting against the x-axis. So if you will observe the arrow mark, that's why we have to take out the minus I. Along in the x-axis we can use the I. So positive x-axis plus I, negative x-axis minus I. Again for along the y-axis, positive y-axis plus j, negative y-axis minus j. In the similar way for the positive z-axis plus k, negative z-axis minus k. So while drawing the diagram, the force is acting at point R we have to find out, right? So that is a net force, and the force is acting, the net force between the point F, the gravitational force acting at point P due to the R we are taking. So that's why we have to measure the distance from R to P, right? So when we are moving from R to P according to the diagram, you will observe that this is a negative. So that's why we have substituted the, for the directional vector minus I we have substituted. Again I'm going to explain you that the force acting due to the ball at P, at point P we have to find out the force. So from R to P we are moving, R to P, that's why we should apply the minus I cap. So here and rest of the part is similar, that the G m1 m2 upon r square, and mass is the same, 5 into 5 5 square, 5g upon 1 square. Remember purposefully we have kept the G as it is, because after while in the next force we can get the substitute the value and get the answer. If someone will do the calculation here, then also no problem, he can get the force there. Again for the Q point also he can find out, and then he can take out the square root, then also he may get the answer there. Okay, just I have kept in the format of the vector, that is minus 25 g I cap. Now the gravitational force acting at point Q we have to find out. So for the Q point you can observe that we are moving from R to Q, means that is along y-axis in the positive direction, so plus j cap. So you will understood that for the plus j cap, again G m1 m2 upon r square. So m1 and m2 have the same value, that is a 5. For the distance we have to find out the 3 minus 2, that is a 1. So here we can keep the distance from r to q, that is a 1 square, and the vector as a minus plus j. So g mq into mr upon rq square. So g 5 square upon 1 square. So we have got the 25 g j. So this is g is a gravitational constant, and j will represent the directional vector. So this is the for the second. Now F net means we should find out the net force. So the net force, now the net force can be written as a F net is equals to Fp plus Fq. So minus 25 Gj plus 25 Gj. So this is in the format of the vector. Now the net force can be calculated by taking out the magnitude of the force. So 25 g square plus 25 g square. So 25 square 625 plus 625. In that way you can get out the answer 1250, and 1250j, and 1250 is nothing but the 625 multiplied by 2. So again you can get the 25g into root 2. Now here we can substitute the value. Root 2 you can take out the with the help of the log table. uh, the value of the root 2 is a 1.41 you can take while doing the calculation, and the value of capital G is a 6.67 into 10 raised to minus 11. So use this value for doing the calculation. So you can get the net force acting at point R will be 2.358 into 10 raised to minus 9 Newton. Friend, this is one kind of the challenging question. So here we can't get the answer directly, so we have to draw the diagram, and after drawing the diagram you should locate the position of the point P, Q and R. So based on that we have to find out. Remember, it is a vector, so this is a vector acting on this direction, this is a vector acting on this direction. So F net will be the addition of these two forces, and then we have got the vector, and then we have to find out its magnitude. So I hope you have understood this question. Friends, make the notes properly and solve the questions. Remember, these all questions are based on the same formula, that is a Newton's law of gravitation. Thank you. Have a nice day.